Hello friends, welcome to my channel. Let's have a look at problem 543, diameter of a binary tree. So in this video, we're going to share a solution based on recursion. So this problem is marked easy in Leetcode, but this is actually a very interesting problem. So first, let's look at the statement. So given the root of a binary tree, return the length of the diameter of the tree. So the diameter of a binary tree is the length of the longest path between any two nodes in a tree. So this path may or may not pass through the root. So this is actually this paragraph contains important information for this problem. So the length of a path between two nodes is represented by the number of edges between them. So this paragraph defines length. So here is example 1. So in example 1, the output is 3. So the a path which has length 3 can be 4, 2, 1, 3 or 5, 2, 1, 3, right? So in example 2, so the output is 1 because the root has one child, that is 2. So the constraints on this problem are the following. First, the number of nodes in the tree is in the range 1 to 10 to the power 4. So in other words, the given node or given tree here is not empty, and the number of nodes can up to 10 to the power 4. So the latter actually is a decent large number. So secondly, the node value is in range negative 100 to positive 100. Because of the number of nodes and the range of values, it tells us that so the nodes can have the same value field. So with that said, so let's look at the method. So the method is based on recursion. The reason is that the binary tree is a recursive data structure. So when we meet context with binary tree involved, we can think of recursion sometimes. So the idea here is very simple. So for each node V, so we found two pieces of information. So first, let's call it dV. It's the number of nodes in the path from node V to deepest leaf nodes or leaf node, so inclusive in the subtree of V. So secondly, PV is the number of nodes in the longest path passing from the node V in the full tree. So actually we can also see here in the tree subtree V. Still okay actually. So with that said, actually let's look at the third part. So the recursion relation actually is very direct to obtain. So here let's first specify the relation and then explain again in the coding part. So here let me introduce some notations in order to fix the idea. So assume that the root is U, and with left and right subtrees, U left and U right. And we have known DU left, PU left, DU right, and PU right. So notice the interpretations of D and P from here. Then we have DU. Notice that DU is the deepest path, the number of nodes in the deepest path from the node U to the leaf node. So this actually is nothing but the maximum of the DU left plus 1 and DU right plus 1. So next piece of information is PU. In other words, the longest, the number of nodes in the longest path passing U. So this actually can have three possibilities. First is the longest path passing from the U left, right? So this is the corresponding number of nodes, and also it can come from the longest path passing from the U right node or the corresponding right subtree. So this is the number of nodes in that path. So or it's possible that it passes through the root U itself. So in this case, so we add the number of nodes in DU left, add those in DU right, plus 1. The 1 represents we count the U itself. So that's the D and PU. So this DU and PU actually contains the information we need, right? So notice that what we are desired to return is actually the length, not the number of nodes. But this, if we compute the number of nodes for the corresponding path in the process, it's much convenient. So with that said, actually we are ready to write the code. But before we do that, let's look at some nodes and extension. So first, in this problem, as we remarked it, so different nodes can have same value attributes. So for example, it's possible we have more nodes, right, than say 200 or 200 plus 1. So but the value is confined to this range. So different nodes can have the same value field. So the second actually is a challenge or extension. Can you write a solution that can determine the longest path that passes any given node in the tree? So here it should be passes. So also it's good to look at Leetcode-543-Diameter, which is a newly appeared problem. The amount of time for binary tree to be infected. So actually the solution here should shed some light on that problem. So with that said, actually we are ready to write the code. So the code actually is very short as we realize the above recursion relation. So for this, first we are going to write a hyperfunction. The hyperfunction is the actual worker for this problem. So I'm going to define it as traverse. So essentially we are traversing the tree. So let's call it root. So first is a base case. So if not root, so we are going to return 0, 0, right? So the deepest path contains 0 nodes. So also the longest path passing the root is 0. So this is actually a very direct. And then we can get information like here, right, for the left subtree and right subtree. So the left subtree, I will call it left. Right subtree information, we are going to call it right. So then we do self-call, traverse root left, and then traverse root right. Let's change this one to be right. And then we are ready to get information from the right and left to yield information for the root itself. So first is the number of nodes. So from root to deepest leaf, right? So this is nothing but the max of left 0, right 0, so plus 1. So actually we can write as max left 0 plus 1 and right 0 plus 1, but we can write here put 1 offset, same effect. But the former may be more informative. So another information is the number of nodes in longest path passing the root, right? So this actually is also very easy to get. As the analysis here, we just need to transform this line of information into the code here. So this is maximum left 1, right? So right 1 and left 0 plus right 0, and then plus the root itself, that is plus 1. So this actually contains all the information. What we are going to return is nothing but the tuple by this 2, right? 1 is this guy and 1 is this guy. So notice that the order here is important. We first return the number of nodes from the root to deepest leaf, and then the longest path passing the root. So with that said, actually we finished the bulk of work for this problem. So next, actually we can we can call the function and prepare the return. So let's call this function. So first field actually is not essential for us. So we are going to call the result to be traverse the root, right? So notice that due to our way of computing n nodes longest passing the root, so each time we compute maximum 1 and the right 1 and the longest path passing the root, so this result actually gives us the diameter plus 1 for this problem, right? Because diameter is the length, right? Here we are counting the number of nodes. So what we want to return is actually result minus 1 if result greater than 0. Otherwise, we're going to return 0. So that's the whole code for this problem. So with this done, let's first do a special case check. Yeah, it passes the first example. Actually, the second example is sort of trivial. Now let's look at the generic case. Yeah, it passes the generic case. Let's try it again. Yeah, actually it should be very fast. So I guess with this done, that's about it for this video. You are welcome to follow up another video on Leetcode-543-Diameter of Binary Tree, which is a newly appeared problem. Thank you very much.